go right.
And then you can go over there and see if it works.
Go right, and then it'd be the store. Like go in the store with you going. So the trick is you'll have one of those like little police check.
Okay, so you go see if that works, and if not, we'll come back. Okay, thank you very much. I appreciate it. Okay.
Parking.
Oh, yes, parking problems. Okay, I understand that perfectly.
What?
Okay, Zach. And David, you want your test?
You just handed it to me.
Did I already hand it to you?
Yeah.
Oh. Did anybody else walk in after I gave out the test? Oh, you done with it? You understand?
Oh, yeah.
You gotta change things to sine and cosine. Yeah, I had a Quizlet on that. It just, I know, it looks so simple when I did it, but.
Yeah, no.
And then combine your, so.
And think of, well, I forgot about bringing it up to two different things. I could cancel that.
Oh, no.
So, you gotta change it to, well, you can work with one side at a time. Either this side or this side. So I saw that this side was here. That's the way you go. Or you change this to this. Go this way. All right. We'll get started in a second here. Just a reminder that 6.1, 6.2 homework worksheets on Shobi due Thursday, I think. So we covered that last time. Get the note. We're gonna do 6.2. So So we did the law of sines last time. I'll put that up just to, well, I'll find my other Oh, the law of cosine. Here it is. Did anybody else come in? You should see their test. All right. Okay, so on this test, we still have people confusing. Let me pull the test up. Okay. Okay, here's one of the tests. Yes. Oh, thank you. Well, I can see it. Okay, so just about this problem and other problems like it, we still have people confusing when we see cosine beta equals 1/5, does not mean that beta, can you see it now? So cosine beta equals 1/5 does not mean that beta equals 1/5. Beta is an angle, and these are sides of the triangle. In fact, what sides are they? The cosine, it's adjacent over hypotenuse. Okay? Okay, so then it says it's in quadrant 4, so you need to draw it in quadrant 4. So adjacent, so I'm going to try to draw it like this. This would be 1. The hypotenuse is 5, and you need to find y, and then y will be negative. So this problem is like a homework problem that we did on Shelby. So, and we had to find sine. So first we had to find y. Well, y is the side of the triangle, so that's the square root of the hypotenuse squared minus the other side squared. Minus. And then you have square root of 25 minus 1 is the square root of 24. Okay, this is just one version of the test. The other version had a similar problem, different numbers. The other version, the square root didn't simplify, so I didn't take off if you didn't simplify this. This does simplify to, 4 times 6, but if you left it as square root 24, since the other version had a square root that didn't simplify, I didn't take off, to be fair. Okay? So, and then another thing, so you get that side, and then you can find sine of beta. Sine is opposite over hypotenuse. That is 2 square root of 6. But what about the sine over 5? What about the sine of this? Down in quadrant 3, y is negative, so we've got to add a negative sign. Okay? So that's sine of beta. So now you have all the information you need to find these things. Now a bunch of you are writing then sine of, you're writing sine of minus 3/5. No, sine of alpha is minus 3/5. So you should be writing minus 3/5. And don't write the sine anymore. The whole sine is minus 3/5. It's, so some people are still writing that. They're writing sine out here. And you're getting confused between angles and sides. These are sides, and we're multiplying them. Cosine of beta is 1/5 minus cosine of alpha is minus 4/5. Make sure you get the signs from the quadrant. This is quadrant 3. And times sine of beta, which was minus 2 square root of 6 over 5. And then some of you, and then it's a common mistake, but to multiply fractions, you do tops times the tops, the bottom times the bottom. You want me to use numerators times numerators, denominators times denominators. I'm trying to make it simple. So it's minus 3 over 25 minus 4 times minus 2 is positive 8 square root of 6, and that's over 25. And then these are not like radicals, so you cannot combine them. So that's minus 3 minus 8 square root of 6 over 25. So that's the sine of alpha minus beta. So guys, I don't know, people are, so you understand that you don't write sine and cosine still, and cosine and sine this whole thing is the cosine. You're substituting the whole thing, okay? And then the next problem, you're supposed to use any of the double angle formulas that you write on your formula sheet. and I use a harder one, I think, but, and then tangent beta is just sine over cosine, or you could have done, or tangent is opposite over adjacent. And pay attention to the sign, what quadrants it's into. Okay, so that, and these do cancel when you have dividing by 5, you have a fraction over fraction with the same denominator. But if it's not 1 over 5 here, then it wouldn't cancel. But okay. Any questions about the test? I'll have you look at it and give it back. And we're going to go ahead and start on the, we'll talk about, again, law of sines for a minute. Remind you what oblique triangles are. Oblique triangles. I'll go ahead and select them if you're done with
Because we worked it out, on the notes, like we didn't put cosine like alpha, we just put it like under the.
Oh,
Yeah, because cosine alpha would be Republican and cosine beta was the theta. I just put them
okay.
under.
Cosine of pi over 2 is not pi over 2. Did you write?
It was because this was. Yeah, because that's the 0, because pi over 2 for cosine is 0, because on top of the unit circle. Right?
Okay. Well, it's because of your notation, I guess, because I'm thinking you're saying cosine of alpha is pi over 2.
Oh, my bad.
And sine of alpha
Was 1, right?
is 1. And I didn't see that. Now you have it here.
I had it there.
And then you don't have sine. So it's your notation.
Just make sure you write correct notation now. Because that is the answer, though, isn't it? Like,
Yes.
Okay.
Yes.
Make sure I at least know how to do it.
You do know how to do it. Okay. So just be careful with your notation. It's kind of what I was just saying about, if you have sine of beta and you have the fractions, just don't keep writing sine. It's like people taking the square root of a number and then they keep keeping the square root. I mean, So, all right. So the next test is the take-home test, and so that we have a time and a day in class to do a retake. But you do have extra work in Stat Lab to do for the retake. It's posted at the bottom of the homework. And so you don't have to do all 3 tests, retake extra work. And make sure, though, Stat Lab doesn't make you write out your work and show things algebraically. Well, I do. So look back at my solutions to my worksheets and make sure you understand that. And if it says, of course, on the graphing problem here that was here, of course you don't need to show that algebraically. That's asked you to use the graph. So, all right. Okay, let me see who's here. Courtney's absent. Brown, right. Daniel's here. I kind of know who's here, so I'm marking it off. Okay. All right. Yes. He's not here right now. David's here, and Teddy's here. Okay. Okay, so we're talking about, so I posted an announcement about that test retake too. So, all right, in an oblique triangle, just remind you, does not contain a right angle, so we cannot use a squared plus b squared equals c squared. Okay? All right. Okay, this is the law of cosines. We used the law of sines when we knew one side and two angles. We use the law of cosines when we have two sides and an included angle is known. So that would be side, angle, side, or when three sides are known. So that's side, side, side. And I posted these filled in notes. I'm trying to find my sheet. All right. I had it out. Law of cosine. Well, I had it all ready, so law of sines. Oh. Angle side angle. No. Law of sine. All right, well, I can bring up the, bring up the book. Again, you can look at the book on your iPad, or you can look in my Stat Lab, or there's a way to look at it through D2L. Or my math lab. Law of cosines, I found it. Good here. Okay, good. Well, all right. Well, you can bring the book up and follow along on your book if you want, because it is really good. The law of cosines is that a squared equals b squared plus c squared minus 2 of angle A. So remember our pictures look like that. If this is angle A letters, and those are the sides. So we have a squared equals b squared plus c squared. If we're looking for a squared, we it just depends which this is for side, angle, side. So minus 2ac between them. C squared equals a squared plus b squared minus 2 angle between them. Okay? So right angle side. We're going to use the law of cosines to find the with that equals. We pick that formula. And then we're going to use the law of sines to find the angle opposite the shorter of the two sides. Subtracting the other two angles from 180. From 180 degrees. Okay, so we're going to do an example. Check your concepts question. Shown in the figure with A equals 120 degrees, B equals 7, and C equals 8. So I'm going to draw the triangle. This is what the figure looks like. It's from the book. So we got A and okay. Small capital C. Small c is 8. Side B is 7. So it's a squared equals b squared plus c squared minus 2bc cosine. Okay, and that equals 7 squared plus 8 squared minus 2 times 7 times 8. Okay. So cosine of 120 is negative a half. You could do it in your calculator, but you got that unit circle. So 56 minus, oh, I guess I just typed it in my calculator because I don't have all this written down. 112 right there? Okay, well, let's bring the calculator up. 12.
What times 8? 64, not 56.
Yep, I was doing 7 times 8. Yep, okay, that's what I get for, trying to do it in my head without my coffee. Oh well. You guys are awake though. Sort of. Oh, wait, that's debatable. Okay. All right. So, and this is. So let's just do it in the calculator. You know, we could just type in this in the calculator: 7 squared plus 8 squared minus 2 times 7 times 8 times negative 0.5. You know. You could have typed in cosine of 120 in the calculator also. But you get 169. A squared equals 169. And then you take the square root, and that's 13. Square root of 169 is 13. Second square root, second answer. Okay, so there's our side. So that's step 1. We found side A. Now we need to find the angle opposite the shorter of the sides. Okay, so the angle opposite the shorter of the two sides is capital B. So we're going to use the law of sines. The law of sines was B over sine B equals, and then we can use, we only have one angle, A. Let's get the calculator out of the way. We only have one angle, A, so that's A over sine B. That's the law of sines. Or we could flip these. And maybe we want to because that'll make it a little easier. So we can flip both of these. It's easier to solve if we get that in our top right corner. So if we get this in the top right corner, if you don't want to flip it, you don't have to. You can just cross over side B, which is 7, equals sine of A. Sine of A is 120, over side A. I think it was too hard for me to flip today. 13. Yeah, I'm getting the same answer I did when I cross multiply. So on my paper, I just cross multiply. So sine of an angle over its opposite side equals the sine of another. And we can just put that in our calculator. Make sure our calculator's in which mode? Degree mode. So we multiplied by 7. So we take sine of 120, close the parentheses, times 7, divided by 13. And we'll just keep 4 decimal places, so sine of B equals 0.4663. So B is going to be the inverse sine of 0.4663. Second, sine inverse for 0.4663 It said just round that to the nearest degree. So B is approximately 28 degrees. And the last step, I'm really out of room here. I tried to give myself a room and still didn't give myself enough room. But step 3, you've got two sides, two angles known. You use the third angle, it's going to be C, it's going to be 180 minus the sum. $180 minus 148 . $180 minus 148. Okay, and we solve the triangle. Solving the triangle means finding all its missing sides and angles. Okay? Any questions? Is that making sense? All right, the next thing, we have the other type of triangle we have is a side triangle. So we're going to use the law of cosines, opposite, the longest side. Either of oh no. Sorry, acute angles. And we're going to find the third angle by from 180 degrees. Okay, so here we're going to do this. So, and we're going to do this with solve triangle ABC. If A is 8, B is 10, and C is 5. So they're giving us 3 sides. Round to the nearest degree. So we need to find. So here's the longest side. Okay. The angle opposite, that's the law of cosines that has a cosine and a capital B in it. So we've got to pick this one with the capital B in it. Equals A squared plus C squared minus 2AC cosine of capital B. 8 squared plus 5 squared minus times 8 times 5 cosine of B. I guess on my paper, you can fill these in with numbers. You get 100 equals 64 plus 25. 89. You have 89 and it's 200 cosine B. Right. No, did I do 200 right? No. What is that? Is that right? Okay. 2 times 8. I'm going to start using the calculator this morning. having a hard day here. Okay. Do not subtract before you multiply. So you don't take 89 minus 80. You get 9 times cosine. That's wrong. You're going to have to. You subtract, you want to get this 89 on the left, subtract that off, and you get 11 equals minus 80 cosine B. Let's get the calculator out of the way, sorry. Okay, so I had to get all my constants on the left, and now and that is approximately negative 0.1. 375. All right. Now you got to find cosine. Now remember, this is negative, and these are actual. Because it's a triangle. It's going to be in quadrant 2. It's going to be something like that. So because cosine inverse B is the cosine inverse of negative 0.1375. You can do that because cosine inverse gives you angles between 0, or you can see on my paper I did cosine inverse of positive and realized that cosine is negative and found it in quadrant 2. But if this was a sine in negative, right, but this is cosine. So anyway, you can either do first of negative 0.1375, and that's about 98 degrees. Okay? Or B is, well, you could take, it's not B, you could take cosine inverse of 0.1375 get rid of this negative sign. And that's 82 degrees. And then draw your reference triangle. This is 82 degrees. The reference angle is always, this is also, it's against the x-axis. So this is 82. But the actual obtuse angle is going to be this one, which is 180 minus 82 degrees, or 98 degrees. And that's the way the book did it. And it's a review of reference angles. Reference angles are always against the x-axis. So it had to be an obtuse angle because it was negative. So sometimes just leaving it negative works. You'll have to see if it makes sense. Okay, it worked here. You don't have to do these steps if it works. Okay. But anyway, any questions? There's two ways of doing that. But the book does it this way. This is what B is then. 98 degrees. Okay. Okay, so the law of sines, we want, doesn't matter which one we find. Let's see, which one did I decide to find? Two, we're going to find, so I found, I was looking for angle A. Using law of sines. Because we know this is the only angle we know. A. And we'll just cross multiply. So filling in those things, we've got B is 10, sine of 98 degrees, 10 over sine of 98 degrees equals 8 known. So if we don't have the unknown in the top left corner, we can cross multiply. That's when you have two fractions with an equal sign between them, you can cross multiply. Sine 98 degrees. And then you're going to divide by 10 on both sides. Sine of A is 8 sine of 98 degrees divided by 10. So 8 sine of 98, and I've got it in degrees already, so I didn't check the mode, but make sure it's in degrees. Divided by 10. You get 0.79 sine of A equals 0.7922. So A is inverse sine of 0.7922. So take second sine, which is inverse sine, 0.7922. And we're rounding to the nearest degree here. So A equals approximately 52 degrees. All right, the last angle we got to find. We know two angles. We'll add those together and subtract from 180. The angles of the triangle have to add up to 180. So number 3, there's not room for it there. Find C, angle C is 180 degrees minus 98 plus 52. (180) minus 98 plus 52. 30. Okay, so we solved the triangle. We were given 3 sides and we solved the triangle. So we had to use the law of cosines to find the angle opposite the longest side. We had to use the law of sines to find either of the 2 remaining acute angles, and then we had to subtract the sum to find the third angle from 180. Okay? All right. And we will be starting on section 6.3 today, I think. We're almost done. This is the last page. So we have an application problem. So 2 airplanes leave an airport at the same time on different runways. One flies directly north at 400 miles per hour. The other airplane flies in a bearing north 75 degrees east of north at 350 miles per hour. How far apart will the airplanes be after 2 hours? So 2 hours, 400 times 2 is going to go 800 miles after 2 hours. This airplane is flying at 350 miles per hour, so that's 350. So the airplane that's flying directly north is going to go 800 miles. The airplane that's flying is going to go 700 miles. And then I just labeled these with, this is the side we want. Apart will the airplanes be after 2 hours? That's just a side B. So we just need to use, this is a side angle side. We're going to use the law of cosines and to find this side opposite the known angle. So, and actually that we don't have to, it's not asking for angle A, C, so we can stop there. That's all the problem wants. They only want B. So we use the law of cosines. And we don't have to do this. So we want side B. So we're going to use the one that says B squared equals A squared plus C squared minus 2AC cosine of B. So B squared equals, all right, so this is, no, C, sorry. Gosh. Switch those around. Minus 2 times 800 times 700 times cosine. Later, 800 squared, whoops, 800 squared 700 squared minus 2 times 800 times 700 cosine of 75. And it's in degree mode already. So we get B squared. Remember, we have to take the square root. Equals 840,122. Okay. We'll just take the square root of both sides. So B equals the square root of this. Second square root, second answer. It's a shortcut. The answer is above the negative sign. You guys know about that? Yeah. I've been doing it. You know these shortcuts on the calculator help. And it says, how many places to give it? I rounded to one decimal place. So B is 916.6 miles apart. If they wanted to the nearest mile, we'd say 917. So they are 916.6 miles apart. And we don't have to find these other angles. Okay, and the last thing is Heron's formula for the area of a triangle. If you don't, so you can use this for these oblique triangles, right? Yeah. We're going to use this formula for of S times S minus one side times S minus the second side times S minus the third side, where S is 1/2 of its perimeter. It's 1/2 of A plus B. We don't know, we don't have the height, so we're using this. So here's an example. Find the area of the triangle with A is 6, B is 16, and C is 18 meters. Of A plus B plus C one half of 6 plus 16 plus 18, and that's 20. In this formula, area, the square root of 20 times 20 minus 6 which A times but you could put it in your calculator at any point. And that's, it's 140. So I said that's approximately 47 square meters. Okay? And that is section 6.2. We're going to go ahead and start 6.3, so if you need to print that, you can print that. And you might want to print this polar coordinate thing out, paper. I think I have it posted in. It's Shelby. Oh, here, I'll show it. That's what it looks like. It's in Shelby. And I'm not sure if it's in D12. Tell me if it is. And if you're done looking at your tests, some people still have their tests, I'll take and collect those. You don't see that?
Go on Titan quiz 6.3.
Do, under
Okay, now I
what?
see. Okay, thank you.
You have,
Quiz. Okay, take home quiz for 6.3. Apparently this polar paper is under in there. And Shelby? Okay, okay. Good job finding that. All right. In your book. Okay, so this is pretty new. We used some of the stuff from before, but then of course, we've got to have definitions. So we got the polar axis. Horizontal ray that extends to the right. So, on your polar paper, if you printed that out, this is called the pole. That's the polar axis. That's the next blank. Okay, so that's the polar axis. It's a horizontal ray that extends to the right. Its endpoint is called the pole. Polar coordinate systems are represented by the ordered pair P equals r comma theta. Instead of x comma y, it's r comma theta. These are the polar coordinates of the point R P. Theta angle from plot the following polar coordinates. Okay, so we're going to plot these. So you could, it's kind of hard to do this. I meant to bring your take-home quiz 6.3. Okay, you need to print that out. So we're going to plot 315. This is 0 degrees. We have to go 1, 2, 3. If this is 3. So this is the point. Okay, so I followed this circle around the 315 degrees, and it was a positive 3, so well, some other people, so people are still printing out the papers, so. The next example is -2 comma pi. Well, you need to know, remember, this paper only has degrees, but we need to remember what pi is. Let me get some color. Okay, so from 2, I'm going to go around the circle to pi, and Yeah, you have to go in a negative direction. Instead of going you could start at the pole, and if it was positive 2, it would be here. But since it's negative 2, we have to go this. Negative 2 pi is here. That looks weird. So, let me open up the book. Oh, we got a couple minutes. Slides too, but here's the book, 1720. You can go to chapter contents or multimedia library. This is chapter 6. E-text. Oh, I'm just going to open up the e-text, and then, or did it not open in this before? Oh, remember I needed Flash? Oh. Okay, I got the book on my iPad. If it needs Flash, to get the pumpkins in here, but that's what stuff here. Let me show you the book. This is page 702. So I'm going on my iPad. To Pearson eText and go into page 702 to show you this. So to plot the point r theta, we have negative 3 pi over 2. We begin with the 3 pi over 2 angle, which I did. Because 3 pi over 2 is positive, we draw theta equals 3 pi over 2, counterclockwise from the polar axis. Now, so we have to plot that point by going out 3 units along the ray opposite the terminal side of theta. Figure 6.22b. So we had to find 3 pi over, we had to start at the pole and go negative 3. The opposite way, away from that angle. Because negative direction, away from that angle. So, just wanted to make that clear. So the last one we'll do today is let's plot negative 1 pi over 2. So, pi over 2 is 180. It's 90, sorry. And negative 1 is here. We have negative 1 pi over 2. Did I get that? Negative pi over 2. Oh, you're right. Okay. We got to go negative direction. So the point's over here. So this point is negative 1, negative pi over 2. Okay, so I have it drawn here too. Okay. Negative pi over 2, and then we start at the pole and go in a negative there because of the negative 1. And the variable